Good morning to one and all. This is Bhupendra Singh Mandloi. Today you will enjoy data structure. In this video, we will see how to add new node in single linked list at last position. In the previous lecture, we already implement a single linked list application in which we add new node at first position into single linked list. Today we will see how to add new node at last position into single linked list. For this purpose, we have to write a new user defined function for which will add new created node at last position into single linked list. So we have to create one more case like case 3. In case 3 we will call add L function and use break statement. Now we have to provide the definition of add L. So we have to write before main function void main void add function. So our purpose is to add new node at last position into single linked list. So we are able to add new node at last position in any case. If linked list is empty, then we can add new created node at last position. If linked list is not empty, then we also can add new node at last position. So first we have to create new node. So for creating new node, we have to show message here. Message is allocate memory for new node. Allocate memory for new node. And we have to call malloc function. Malloc function will return the address of memory block for node. Malloc size of memory. Size of node. We have to pass node here. Now we have to enter data into created node. So we have to again show message here in printf. Enter data into new node. We have to use scanf function for reading data from standard input device, that is keyboard, and our node contain integer type of data. That's why we have to use here %d specifier for integer, and we have to pass the address of ptr pointer info part. Now our purpose is to add new node at last position. So link part of last node in single linked list having null value. So we complete put the value null at link part of created node. So we have to write ptr pointer link equal to null. Then here our node is completely created, in which we already set data, and already set the address part, which is null. Now we have to check what is the position of linked list. It might be possible linked list is empty, so our start pointer variable will be null when linked list is empty. So we have to add node as a last position. In this case, however, we will add new node that will be automatically will be in the first place or automatically will be at the last place. So we have to pass address into start variable, which is already contained in ptr, and here node is added at last position or node is added at first position. So we have to return from this block. What happened when linked list is not empty? So we have to traverse existing linked list and we have to find address of last node. So here we are using a low pointer variable which contains address of first node. From first node to last node we have to visit using the while loop, and we have to write here what is the speciality of last node. Every last node of single linked list having the link part is null. So we have to write here condition while low pointer link not equal to null, not equal to null, and we have to move from the next node if our condition is true. So we have to write here address of next node, loc is equal to loc pointer next. It will work as a link. It will work as a counter. So after executing this loop, loop will contain address of last node, So we have to set address part of last node, that is low pointer link, equal to ptr. Then our node is added into single linked list at last position. Now first we have to save our program, then compile. Oh, one error here, multiple declaration for add first. Multiple declaration, we have to write here add L. Again save, then compile, then run. Okay, we are missing something because in the message part we missed the case 3. So exit from here and update our program, provide the exact information to the user. Here we have to write /n enter 3 for add last. That's it. Again save our program, Alt F, save, again compile and run. So here when we enter 1, then our node will be added at first position. When we press 2, then linked list will be displayed. When we will press 3, then node will be created and added at last position into single linked list. So I have to press here 3. I want to add new node at last position. So here I want to enter data 100. I want to again choose 3 and enter data as at 200. Now I want to see the linked list 100 and 200. Again I want to add 500. 500 will be added after 200. So 500. Again I want to see the linked list 500. Now I want to add new node at first position. I will add 1000. So 1000 will be added at first position. Now I want to see the linked list. That's it. Now I want to change little bit in our program. We'll change the position of CLR SCR function. We'll change the position of CLR SCR function which is written because our menu will be C at once only. So I have to write here CLR SCR function here. Now again I want to save and again compile and run one more time. So will be clarity about the complete program. Now I want to enter 1 for add new node at first position. So I want to enter 200. Now I want to again add new node 100 before 200. Now I want to see 100 and 200. I want to add new node at last position and node will be suppose 500. Now again I want to see the linked list 500. Again I want to add new node at last position. Value will be 1000. Again see the linked list. So if you will practice this program, then you will be able to write complete linked list and you can create your own ideas. So hope you will enjoy this program. So thank you all of you. अगर इस प्रोग्राम में आपको कुछ प्रॉब्लम आ रही है तो इसके पहले जो हमने फर्स्ट वीडियो में लिंक लिस्ट का प्रोग्राम बनाया था, एड फर्स्ट नोड न्यू नोड एड फर्स्ट पोजीशन इनटू सिंगल लिंक लिस्ट, तो वो देखने के बाद आप ये वाला सेकंड फंक्शन ऐड करने की कोशिश कीजिएगा, आपसे आसानी से हो जाएगा। और ये प्रोग्राम एक दो बार बनाकर देखिएगा, डेटा स्ट्रक्चर सब्जेक्ट में आपका कॉन्फिडेंस भी बिल्डअप हो जाएगा। और प्रैक्टिस करते रहिए, प्रैक्टिस मेक्स अ परफेक्ट मैन। थैंक यू ऑल ऑफ यू, दैट्स इट।